my project is on the effects of carbonate on nitrogen fixation of cyanobacteria. Nitrogen is the most abundant element in our atmosphere. It's the primary nutrient for green plants, but it has to be modified in order for it to be readily utilized. The process of nitrogen fixation reduces molecular nitrogen to form ammonia, and this process is carried out by nitrogen fixating bacteria in soil. In today's world, with the rising level of carbon dioxide in the atmosphere, I wanted to know the effect of carbon dioxide on the nitrogen fixation process of bacteria in soil, which in this case is cyanobacteria. Cyanobacteria are a phylum of bacteria found in oceans, bare rock, fresh water, and soil. And these bacteria obtain its energy through photosynthesis. The purpose of this experiment was to examine the effects of different amounts of sodium carbonate on the responding variables of cyanobacteria, such as the pH levels in the material in the petri dishes and the amount of ammonia released. So the first thing I did was I got 12 empty petri dishes, three for each of the 4 types of cyanobacteria cultures. And with the marker, I marked 4 dishes with 0%, 5%, and 10%, which was the amount of sodium carbonate. Then I measured the mass of the petri dish with nutrient agar and cabbage juice, and then subtracted it from the mass of the empty dish to obtain the mass of the agar. Then I multiplied the mass by 0, 0.5, and 0.1 to get the amount of sodium carbonate needed for the respective dishes. Then, with the plastic pipette, I added 3 milliliters of cabbage juice to each dish and I mixed it. I added hot nutrient agar and left it to gel up. Then I added 1 milliliter of each type of cyanobacteria to the petri dishes and left them to gel up, and I placed them in the climaterium under white light. Then I took a well plate and filled the top row of microwells with distilled water, and I added universal indicator to the rows. The colors should range from a red to a dark violet. Each day for a week, I took the petri dishes to examine the growth and pH color change resulting from the nitrogen fixation process. So for my data analysis, over the 7 days, the petri dishes showed much growth of bacteria, but there was a lack of cyanobacteria, which is the blue-green bacteria. There was no sign of a pH color change to indicate the effects of carbonate on nitrogen fixation. This was the same for each of the types of cultured cyanobacteria when grown under white light. The cabbage juice indicator, when poured in the microwells, did not match the pH colors shown by the universal indicator. So in my future studies, I would use a universal indicator in order to observe the pH color change. And I would also try to use a different type of bacteria instead of cyanobacteria, and I would hope that it would be beneficial. So that is my project.